Okay. Okay. So last class we stopped here. We saw how to plot the histogram, how to construct the probability distribution table, and also sample space. Now, today we will learn about parameters of probability distribution. Okay, so you have already studied about mean, variance, and standard deviation in the previous chapter. So in the same way, we will be defining mean, variance, and standard deviation for the probability. Okay, and this is the formula for mean, variance, and standard deviation. So you do not have to study these formulas. You will have these formulas in the formula sheet. It will be given on your test day. Okay. So we will straight go to the example. Now they are asking us to find the mean, variance, and standard deviation for example 3. So let us look at example 3. Okay. I don't think so. This was the one. Example 3 does example 4. Okay. So in example 4, we found the probability of number of heads. Okay. So this is like if you get 0 head, that means all 3 are tails. So the probability is 1 over 8. How did I get this 8? The total number of sample space. Okay. Likewise, for 1 head, it will be 3 over 8. So this we studied in our previous class. So we will use this information to find the mean, variance, and standard deviation. So I'm just writing the probability in a decimal format. 0.375. So this information is from example 4. Okay. 0.125. Now, how do you get the next column? Just multiply x and p of x. Multiply the first column with second column. So this is 0 into 0.125. I get 0. Next. What is the next value? 0.375 and 0.75. I need answer from this column. What will be the last value? Multiply 3 with 0.125. Okay. Now, what does the summation symbol mean? What does this mean? Sum. Very good. Sum. That means you're supposed to add all these values. Okay. So if you add all these values, you must be getting 1.5. Did you get 1.5? Okay. So this is called as mean of the probability, denoted by mu, or we can also denote it by E. Okay, so this is how you calculate the mean of the probability distribution. Now, how do you compute this column? You have x, you have mu. What is mu? Mean, which is 1.5, right? This is mu. Now, how do you compute the next column? 0, which is x, minus 1.5, which is equal to minus 1.5. What is the next answer? And 0.5 and 1.5. Okay. In the same way, compute the next column. How do you compute? Square, right? Multiply this twice or square this. 1.5 the whole square, 0.5 the whole square, 0.5 the whole square, 1.5 the whole square. What is the value? 2.25 and 0.25, again 0.25, and then we get 2.2. So how do you compute the last column? You have x minus mu the whole square. You know p of x. So just multiply this column and this column. Okay? This is first column, second, third, fourth, 5, 6. So to get the sixth column, you are supposed to multiply the fifth column with second column. Multiply and tell me the final answer. That means you have to add all the values in that column. Okay? You did? I need the final total answer, summation of this column. That means you have to add all the values you got. Point 0.75. So this is the mean and sigma square is the variance. Okay? Sigma square is the variance. Now we got mean, which is equal to, which is represented by mu, which is 1.5. Variance denoted by sigma square, which is 0.75. Now standard deviation is equal to what? You have variance. How do you compute standard deviation? Standard deviation is denoted by sigma. That means exactly square root of 0.75, which is 0.866 roughly. Okay, so this is how you compute the mean, variance, and standard deviation. You just have to know how to construct this table and you will be done. Okay? I guess you can also do this using calculator, but I'm not sure how. You also have videos in the Blackboard, so you can just take a look at that. Now, expected value is nothing but the mean which we already studied. Okay, it is also represented by E. Now, let us look at example 6. So, this is similar to your lab 4, I guess, lab 4, where you were supposed to find the probability of winning and losing, right? So, it is similar to that. Now, take a minute to read this question. You have $5. Now, there are 2 games to be played. You're supposed to bet on number 7, and in the next game, you're supposed to bet on the pass line. Okay, now there are 2 games, so we will look at the roulette first. Now, if you bet for $5 on number 7 in the roulette, they're saying that the probability of losing is 37 by 38. That's the value they have given. And the probability of making a net gain, which is nothing but the profit, is 1 over 38. And this is how much you get if you win. Okay. Now, let us look at and they are asking us to find the expected value is nothing but the mean or the average, right? Okay, let us look at the next game. Here also they are betting $5 on the pass line. Probability of losing is 251 by 495. Probability of making net gain is 244 by 495. Okay, now here you're supposed to find the expected value. So there are two games, so two tables, you're supposed to find the mean. Okay, so this is how I made the column. Now here I will write as lose or win. Okay, there can be only two probabilities. Either you win or you lose. Okay, so how much do you lose? Now this is for Roulette and this is for the pass line. Okay, now let us do the first table. Okay, first table. Now if you lose, you will be losing $5. That's what they said. Now if you win, you will be winning $175. How did I get this? Here 175, and if you lose, it is $5. Okay, now how do you find the probability? You don't have to find because it is already given. Probability of losing is 37 by 38. Probability of winning is 1 over 38. Okay, so 1 over 38. Now how do you find the x into p of x? Multiply the first and second column. How much do you get? Roughly. And next is 4.605. Okay, so how do you find the mean? Add. Mu, or it is also called as E, is nothing but summation of this p of x. How much do you get? Total summation of x into p of x. How much do you get? Okay. Now here also we have two things, lose or win. Now this is for pass line game, second table. Okay. Now here if you lose, you will be losing $5. If you win, you will be winning $5. So this information I got from the question here. Okay, so the probability of losing is 251 by 495, and the probability of winning is 244 by 495. Multiply. Must be getting minus 2.53 and 2.464. So if you add these two, you will get minus 0.07, which is nothing but the E. Okay, so let us summarize. Now, if you are playing roulette, the expected value E is equal to minus 0.26. And if you are playing the pass line game, the expected value is equal to minus 0.07. Now, which is better? Which game is better? If you look at this value. Why? Very good. So you said the expected value to lose is roughly 7 cents, right? Now, why did I say lose? I can also say win, but why did I mention only lose? That's because of this negative value. Okay, for example, if this was plus, then this game would have been better because that is 26 cents. Okay, so you have to be careful with this negative and positive sign. If it says negative, that means you're losing. Okay? So this is your point. Section 5.2, binomial probability distribution. Now, if you want to call a probability distribution as binomial, then these are the requirements to be satisfied. Okay, what is that? It must have a fixed number of trials. That means in lab, you were adding 10,000 or 1,000 simulations, right? So those number, 1,000 or 10,000, whatever you were adding, those are called as trials or simulation or row numbers. Okay, so those numbers must be fixed. And the trials are independent, which means it should not depend on each other or it should not affect the other event. Okay, trials must be fixed and independent, and they must be exactly in two categories. What does that mean? It means that, for example, like roulette game, win or lose, there are only two outcomes, right? Or if you toss a coin once, outcomes are only two, heads or tail. Okay, so those trials are called belong to binomial probability distribution. Now, the fourth one is the probability of success remains the same in all trials. That means if you use the other number of trials, the probability of success must be same for all number of trials. Okay, so we will look at some examples so that you can understand easily. So for a probability distribution to be a binomial, it has to satisfy all the four requirements. Not one, all the four. Okay, now first example. 291 couples used the Y-sort method to give birth to 291 babies, and the weight of the babies are recorded. Okay, the weight of the babies are recorded. Is this binomial probability distribution? No. Why? Because the weights or the value of weights can be more than 2, can have more than 2 possibilities. What do I mean by this? That means, so there are 291 babies. If the first baby is weighing like, say, 1 pound, second baby 2 pounds, third baby like 5 pound, right? It is more than 2 different values. So this is not a binomial probability distribution. Okay. Now, second example. The same example, only difference is in this part. Yes or no? Yes. Because it is genders, it could be male or female. Only two possibilities. Only two possibilities. Okay. Third example. Answer from that side. Is this a probability distribution, binomial probability distribution? Yes. Why? Very good. Because of this. Okay. They're saying it could be, it was recorded as potatoes or other. Only two possibilities. So it is yes. Because two possibilities. Last example. Easy answer. There are more than two outcomes. So it is no. More than two possibilities. Okay. So this is how you categorize whether example or a survey is binomial probability distribution or not. Now let us look at some notations. I'm sure you would have known this. Okay. So here we denote S as success and F as failure. Okay. So from now on, we will denote success as S and failure as F. Now, P of S is nothing but probability of success. P of F is nothing but probability of failure. So we will also represent probability of success by small p. Okay, small p. Now, how do you find the probability of failure? It is nothing but like A complement, 1 minus P of A. In the same way, 1 minus small p. Okay, 1 minus probability of success gives you Q, which is probability of failure. Very important formula. Okay. Now, N is nothing but fixed number of trials. N is nothing but fixed number of trials. X is number of successes or number of outcomes. Okay. Small p, you know that it is probability of success. Q is probability of failure. Now, capital P of X is probability of getting exactly X values. So this notation you already know. Okay. So let us look at another example. So here we are supposed to find out the values of N, X and Q, X, P and Q. N is number of trials, X is number of outcomes, P is probability of success, Q is probability of failure, which is equal to 1 minus P. Okay, so before that, we need to find A. Okay, does this procedure result in a binomial distribution? Now, for a survey or something to be a binomial distribution, it has to satisfy four requirements. Four requirements which we studied earlier. That is, number of trials must be fixed. So look at the examples and tell me what is the number of trials. Are they independent? Are there two outcomes? And is the probability same for all the trials? So what is the number of trials in this question? Exactly 5. So here trials are nothing but people's number of people. So it is 5. It is fixed. There is no change or there is no number given for number of trials other than 5. So it is fixed. So first requirement is satisfied. Second one, are they independent? Yes, they are independent. How many outcomes do you think we will get? 2. They know Twitter or they do not know. There are only 2 outcomes. So yes, 2 outcomes. Is the probability same? Yes. And what is the probability? 0.85. And the probability for each person is same. They will not change. So what can you conclude from this? It is a binomial distribution. Now that we know it is a binomial distribution, we can find out the terminologies mentioned here. What is n? N is nothing but number of trials, which is 5. What is x? Yes, 3. What is small p? Probability of success. 0.85. What is q? 1.5. 0.15. How did you get that? 1 minus 0.85, which is equal to 0.15. Okay, this is the formula. 1 minus p. Got it? So this is how you find out n, x, p, and q. So you must know how to find this, because this you cannot do in a calculator. Now, after you find all these terminologies, you are going to solve another example. Okay, so this you can do using two methods. Using the binomial probability formula, I'm sure that you will not use this method because method 2 is very easy. So you can use calculator also. Okay, so we will look at two methods here. Now I'm using the same example. Method 1, we have already these values, right? N is equal to 5, P is equal to 0.85, Q is equal to 0.15. Now I will use the formula mentioned here. P of x equal to n factorial divided by n minus x the whole factorial into x factorial. P of x. So this is the formula for binomial probability distribution. Okay, we know all these terminologies, right? We found in the previous example. Now just plug in those values to the formula and find the answer. Divided by 5 minus 3, the whole factorial. How much do you get? 0.38. Okay, so this is the probability of getting exactly 3 adults who knows how to use Twitter. Okay, now method 2 using calculator. So this is a virtual TI-83 plus. You can also use 84 or Kessler. Okay, so how can we find the same thing, the binomial distribution here? Now click on second. Second method, click on second and VARS. You have VARS on your calculator. Second and VARS. Scroll down. That means you just have to hit the down button there and choose A. Okay, binomial PDF. A. Click on enter. Click on enter. Now enter those values. So I need n P and X in the same order. N is 5, comma, P is 0.85, so 0.85, comma, X is nothing but 3, so click on comma, close the braces, done, and enter. You get 0.1649. What did we miss? Yes. Oh, it's binomial PDF, that is 0. So here it is 5.85 and 3. Close braces, enter. It's correct. Okay, so let me do it again. So this was not A, this is 0. Don't use this. This doesn't work. Second was go to 0 here, enter binomial PDF and enter the values, which is 5. I'm just doing it again. 0.85, that is n comma p comma x always, and 3. Close braces, enter, you get 0.138. So you can use calculator or you can also use the formula. So probability of getting 3 is 0.138 using calculator. Okay, so we will look at the other examples in the next class.